Welcome to a new test and teardown video. This time it's definitely some military equipment, a signal generator. SG-85 URM-25D HF signal generator. Huh. Don't you just love old military equipment? It is just made solid. So there are actually quite a few things I don't understand by looking at this front. Well, okay, we got the fuses, we got power, that's easy. We got ground, that's probably a power indicator. That will be the megacycles, and then we can tune the frequency. All that is easy to understand. So this is the different bands. We got 8 different frequency bands, so that's probably a carousel switch in here. Really tough to. So that will be in kilocycles, and then it's indicated up here. So far, so good. But now comes trouble. RF output, X multiplier. Let me get up a little bit of an external modulation in, audio out, or external calibrate out. I think this depends on what kind of modes we are in here. So that switch works quite all right. So that is our RF output X multiplier. And then, so what are we multiplying here? Is this the level, or is this the frequency times 10 frequency, or a 10th? Or is this 10,000? No, this is 10,000 men. So this is times 1, right? 10,000s. That can't be it, right? Because why don't you write a RF level multiplier or something? This is confusing because it goes all the way to 50 megahertz. So I mean, that is impossible. So it can't be frequency. But there's also microvolts. So that is level, okay? RF output X 200K open circuit. What does that mean? And then here again we got some frequency 10K to 30, and then X multiplier, and then X 200K and X multiplier. I don't understand exactly what that is. And obviously we don't have a manual, so that is of course the carrier. This is probably the drive to the output stage. You calibrate the output so it's correctly. Modulation. And then there's a trimmer hidden in here. So yeah, that is the unit's front. Of course, you can just wind the mains cable here. And then on the front, oh, you gotta see this. This is inside the front lid. This one was here at the very front, and then it was closed like this. Of course, military markings, super cool style. This is just how they love to mark stuff. So here we got a little bit of, oops, it's upside down, sorry about that. So that will be the accessories. Pots, and they look like somebody soldering on them, so that will be old pots. We got some attenuator and impedance adapter. Probably a load or something that says adapter for something, I don't know what. Another test lead thingy. Spare fuses and another funny adapter. And a antenna simulator. nicely silver coated boxes. And then everything here is written in Danish. So this is of course from Danish military. Let me see if I can get a better indholdsfortegnelse. So that is a list of what is in this box. Fixed attenuator, impedance adapter, and test lead antenna simulator. I think we got all of this. Fuse. And then a total of 15 items. The only thing I really go absolutely nuts about all the time is this. Umbraco. It's called Umbraco. It's an N. So every time you write Umbraco, you reveal that you absolutely got no clue about what the heck you're doing. Please tell everybody to write it correctly. Thank you. So before I power this up, I think it's always a good idea to do a little bit of homework. So this is the top of the unit. Supply 115 volts, one phase 50 to 1000 hertz. Wow. And again it says this AN URM-25D Navy Department. Nice. And then we got this power plug. That is definitely USA. So that means let's give it 115 and see what happens. I believe we are ready for the first power up. Let's see what happens. First I like the power switch to be off. Then add mains. And nothing bad happens. We got light. 62 watts and then it goes down to 40, 30. So 30 watts. I expect it to rise. Yes, so 40. And we got output. Aha. That is a good sign. 45 watts. I don't see anything here. I am now connected to that output. Okay, let me play a little bit with settings and then I will continue. So let's play a little bit with this unit. RF multiplier is of course RF level. So if I dial down like that, right? So all that is level. Microvolts here is also level. And as you can see, that pot meter definitely need a little bit of service. We also got something here with I don't really like this with the needle that just hammers all the way up. And it says here, set carrier to 10 microvolts, control fully clockwise. And if I hammer this fully clockwise, that can't be right. So the idea is I put it like that, right? So this has something to do with frequency multiplier. Look at that. So there should definitely be a doubler or something running now. But that is not working too good. So that is probably, or maybe it's another output. Maybe it's that one, right? Yeah, maybe it is. But anyway, let's play a little bit with the different frequency settings. Here it says 30 to 95 kilocycles, and I got 73 kilohertz on the scope. And let's see if we can read. It says 70 and then 1, almost 2. What? And I got 73 kilohertz. So it's not that bad, isn't it? So that should be 70. And it's actually 70. So yeah, I can definitely adjust the frequency output here, so it's looking like it's working. And that is 10 to 30 kilohertz. That works as well. It's using about 47 watts at the moment. Oh, at 113 watts. So let's give it a little bit more. So it's 115. And then the power consumption is 48 watts. So that is perfect. I'll play a little bit more. So now I am in 3250 megahertz, and I adjusted the output to 50 megahertz, and I read 49.97 megahertz on the output. It's very frequency, or the level is very frequency dependent. So when you change frequency, it's really good to use the meter here and then adjust for correct amplitude. And that is of course what this meter is used for. The more I use this pod, the more nice and clean the output is. So far so good. It seems to be working. We got a crystal and we got some external. Ooh, we can have a lot of. That's probably modulation and stuff. Yeah, let's see if we can get some modulation. So working with the modulation, it seems like the modulation oscillator is not running, or I'm just maybe in external modulation. Somehow I haven't figured out how to do this correctly. What can I do here? What am I doing wrong? Because I don't get modulation no matter what I do here. But I see some noisy here, right? Here you go. You see all this? So that means the AM modulation system is working, but the oscillator is not working. There should be an internal oscillator. I would expect this to be 400 or 1000 hertz of modulation. You can select between this or you can go external. Hey, let's try and input some external modulation and see if that will work. That should be like that, right? And here is external modulation, on and off. So yes, it works with external modulation. So we have an oscillator that is not working in here, but other than that, it seems to be working, this unit. So time for teardown. Why is it always such a fight to get stuff like this out the case? There's always a few millimeters of space missing, and that creates a lot of hassle and fight. But we are in, and I see a loose little screw down here, and I see two connectors, and that will be the power supply. Wow, really nice. So let me unplug the two connectors and then carefully move stuff a little bit here around so we can inspect what we got. So here's the power supply unit, classic military style. They want to make stuff as simple as absolutely possible, using as little as possible different components as well. So that means you're stock less spare parts, and it's just super easy to repair on the fly. So this power supply is probably the most simple you can imagine, right? This is mains input, and that will be the voltages output. Rectifier tube, filter choke, and 3 capacitors. And here on the inside, that's all you got. Beautiful, beautiful, fully sealed, shielded, and all that kind of stuff. Mains input, yeah. And everything is numbered, even from the inside. All the parts, they are numbered. So there's a nice, good reference. And those capacitors, by the way, they are wet. They are filled with oil. So they are using oil for paper and oil and stuff like that. So they will last forever, and they're completely sealed. And they probably do a lot more than specified when it comes to voltage. And I bet if I measure one of these, I'll probably get exactly 4 microfarad. It depends a little bit on the specifications. Was this minimum 4, or was it, you know, it's just a little bit dangerous to touch them, because the self-discharge in this kind of quality components is like close to 0, and you see no discharge resistors in this power supply. And I just powered this unit up, so it could potentially be a pretty shocking experience to touch any of those 3 capacitors. Okay, let's do that. It's fun anyway. So I remove this nut and remove this, and there was only 2 volts left, so I believe this meter should be able to measure. Let me see. How about that? 3.8 microfarad. So that's definitely within tolerance, and this was probably also the initial value of that capacitor. How amazing. I mean, this unit is probably from 1940 or something like that, plus minus, I don't know, 5-10 years. Well, I only got a few things left to say about the power supply. I mean, look at the transformer here. 150 volts, but it's huge frequency range. That is amazing. And why only 115? So it was only designed for US use, not export. Definitely when they designed this, they did not have export in mind. Also, look at this, max altitude 10,000 feet. This transformer is completely sealed, so you don't need I mean, really? That is so stupid. So let's look inside the signal generator. We are looking at the bottom. So this is the switch, or this is the connector, of course, to the power supply. Mains entry, a really nice filter. You can even see it consists of 2 inductors and 2 capacitors. 2 fuses, that is really nice. The on-off switch, and then we go to the power supply. That's kind of what it is. Got feed through capacitors for everything inside the super nice and stable oscillator box. We've got a few tubes for all the good stuff. And that will be the output attenuator. Remember the multiplier I talked about? So here's the input to the attenuator, and the output is here in the middle. I've been opening a few of these before, so you know how this looks. And the output goes in a round circle with contacts all around and resistors all along the line. So the signal just gets weaker and weaker and weaker and weaker, and then you connect to the set where it's where the level is you want. See, somebody was in here doing some service. So we got some marking, and here's a fun thing. Click. They don't really align that well, do they? Oops. But it's, I think the click and hold is done in the attenuator, not in here. So this is just a, yeah, you see, just a feed through shaft. And that will be the 2 missing screws. Look at that, I found 2 loose screws inside the cabinet. So somebody didn't do their job correctly here. That is a little bit disappointing. But we need to go in here and see if there's any cool things in there, right? That is what you came for. So I've removed all the screws from this lovely unit. And ta-ta-ta-ta. That is just beautiful. Wow. There is definitely a carousel switch. Oh, that is some solution. That is a tough spring. And this seems to be a fiberglass. Click. Look at that. So it's full of tubes in here, right? 1, 2, 3, 4, 5. It is beautiful design. So that is the frequency fine adjustment, and this is the carousel. Whew, I am impressed. That's the crystal oscillator for calibration. Somebody was in here. I love it. This is great. What kind of tube is that? So this is just a 6 AG7, but it's a JAN, Joint Army Navy, military specified. Is it any better than any regular 6 AG7? Maybe it is, but at least it's specified to be a little bit better, maybe. It is a beautiful design in here. I've been looking a little bit on the other tubes, and that will be the oscillator tube, by the way. And that is that will be all the contacts for the carousel. We got 4 contact points, probably for capacitors and inductors and stuff like that. See, 4 contacts. Boing. And that goes to the oscillator circuit here, and then the fine tuning is obviously the variable capacitor here. And none of all the other tubes there are JAN specified, only that one. And up here on the outside we got the power supply, and that's easy to spot because that will be a voltage regulator tube. And of course you need your feedback control done by a double diode, and you need the output power handled by a power pentode. So that is definitely a classic high voltage regulator done by that. So that is what we'll find inside this beautiful signal generator. Ooh, that is not a good idea to touch that, by the way. I can feel that now. Oh, that was stupid, man, because that is glass fiber or some other asbestos fibers. Oh man, stupid. And by the way, why is this roller rolling on top of that, creating all sorts of microfibers in here? And if you look carefully, I could actually see a little bit of glitter here on some parts. So that means we got micro particles of fiber here. I don't want to breathe that shit.